Hey guys, it's Mrs. Coles. Happy Monday. Today is the 13th. If you want to, you can actually go ahead and start a new chapter in your binder checklist. And it doesn't matter if you're in my block class or if you're in my honors class. We're actually taking the same notes all week of your paper if it's a little bit different than mine. A brand new chapter. We are on chapter 7. So it's mostly about similarity. You'll notice that some of the things we're going to talk about, you guys have actually already learned. So part of it will be review. So let's go ahead and get started. So we're going to talk about topic 1 today, which is just triangle similarity. Let's go into detail and what makes them congruent. So I have some bullet points here. So what does it mean for figures to be similar? Well, it means you have the same shape, but your figures are going to be different sizes. Now, if we actually go into a little bit more detail, when you talk about the corresponding angles of similar shapes, their corresponding angles are going to be congruent, meaning the angles from one shape to the next are not going to change. So let's write down that they have corresponding angles. Now, when you think about the sides of similar figures, the sides are not going to be equal because one figure is usually bigger than the other figure. So they are going to have different corresponding sides, but if you remember, they're going to have proportional corresponding sides. So we'll just write down that the sides are proportional. Now what this means is if you were to find the scale factor from the pre-image to the image for all of the 3 sides of the triangles, you're going to get the same scale factor every time. So let's just write down that you're going to have equal scale factors. Now when you have congruent shapes, that means everything is the exact same. So when you think about their corresponding angles, all of the corresponding angles are going to be congruent. So we're also going to write down that they have congruent corresponding angles. And when you think about the sides are not going to be different from each other. The corresponding sides are going to be the exact same. So their sides are going to be congruent. So I'm just going to write down corresponding sides are congruent. So this is everything we focused on last week in our last chapter. So we actually learned 5 postulates to prove that triangles are, and oh, I have a typo already. This should actually say congruent. We learned 5 postulates to prove triangles are congruent, the exact same. So if you think back to those 5 postulates, you have your SSS, you have your SAS, your ASA, your AAS, and then that last one we learned was HL, hypotenuse leg. You only use that for right triangles. We also did learn leg, LL, which is also used with right triangles, but we really don't use LL because it's really the same thing as SAS. So for this entire chapter and for today, we're going to talk about 3 ways, also known as criterion, 3 criterion to prove that triangles are similar. And you'll notice that some of these criterions are very alike to the postulates, but they are a little bit different. So I'm just going to go through each of the criterions. You first have your angle-angle similarity criterion, also known as your AA similarity. Then you have your side-side-side similarity criterion, abbreviated as SSS similarity. And the last one is your side-angle-side similarity, also known as SAS similarity. So you'll notice that after all of these abbreviations, there's this little squiggle. It's called a tilde. Okay, that just means similar. So shapes are similar. So you can read about each of the criterion here, but on the bottom of the notes and on the back of the notes, we're actually going to go through each of these criterions with an example. So let's go ahead and start with example 1 here. So it says, determine if these triangles are similar using one of the criterion. So let's take a look at what kind of triangles we have and what information's been given to us. So you'll notice that you are given information about 2 pairs of sides. I'm just going to jot that down. And then you're also given information about a pair of angles. And you'll notice that the pairs of angles, those 37-degree angles, they're right in the middle of your pairs of sides. I'm just going to put that they're in the middle. Okay, another word that we use for middle angles is included angles. So let's take a look at the sides, and anytime you have sides and you're trying to prove if the triangles are similar, you're going to want to find scale factor. So let's start with our scale factor. It's just a fraction. If you guys remember, it is putting an image length over a pre-image length. So if I take a look at my 2 triangles, since I don't actually tell you which one is the pre-image and which one is the image, just read it from left to right. The first figure will be the pre-image. Think of it as like the before image. And then the one on the right is your image. It's the after. So I'm just going to make my scale factor using my 2 pairs of sides. So if I take a look at my first pair of corresponding sides, 3 and 6, I'm actually going to put 6 over 3. When you reduce that, you just get 2. So I'm going to do the same exact thing with my other pair of corresponding sides. You have 5 and 10, so we're going to put 10 over 5. Again, you get 2, which is awesome. If you started doing this, and if you got 2 different scale factors, right away you can just say, my triangles are not similar. Okay? But so far, they are similar. Now, you'll notice that we're given that 1 pair of angles, and it's directly in the middle. And those angles are equal. So if I go up to my 3 criterion, I'm not going to use AA. I'm not going to use SS. I'm going to want to use this side angle side similarity criterion. And that says if the lengths of 2 sides are proportional, which we just found here, we have equal scale factors, and the included angles are congruent. So remember, included angles just mean middle angles. So those are congruent, then the triangles are similar. So we can finish example 1 by saying, yes, they are similar. So I'm actually going to write that down. Yes, they are similar using the SAS similarity criterion. So that is what the SAS similarity criterion looks like. So let's take a look at the next one. So example 2 says determine if these triangles are similar using one of the criterion. Well, if you look at the 2 triangles, you'll notice that you're not given any sides. You're actually just given angles here. So let's take a look at the 2 groups of angles that we have. Angle A is congruent to angle O. They're both 77. Angle N is congruent to angle Y. They're both 48 degrees. So I have two pairs of angles. That's it. And both of those pairs of angles are congruent. So if I actually go up to my similarity criterion, this is an example of the first one, angle-angle similarity. Because it says if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So we can just say, yes, they are similar using the AA similarity criterion. Now, since we've actually been given the letters for these two angles, we can create a congruent statement, which I do want you guys to practice if those letters are available to you. So we've been doing this. So remember, a congruent statement is just when you are naming the two triangles. Oh, you know what? I'm sorry. This wouldn't be a congruent statement. It would be a similarity statement. I'm so used to what we were doing last week. We're going to create a similarity statement because these figures are not congruent. They're actually similar. So let me scratch out my congruent symbol. They're similar. But it's just like we were doing last week. We're going to name both of the triangles. We're going to say that they're similar, so I'm using the similar symbol in between them. But I just want to make sure that my angles are matching up. So if I were to call the first triangle ANM, I'm going to make sure my second triangle is called OYB. Now, if we actually take a look back at example number 1, we technically could have also used the AA similarity criterion. Because if you notice, we actually do have two pairs of angles. I just chose to focus on the two 37-degree angles. Not only do we have those top angles, but we also have these right angles on the bottom, which are both 90. So if we didn't want to use SAS, we could have also just said these two triangles are similar using the AA similarity criterion. All right, so the only one we have not talked about is the SSS similarity criterion. So that's on the back. So again, determine if these triangles are similar using one of the criteria. So here you'll notice you're not given any sides. Now, again, you're given sides. We want to find scale factor. Anytime you're given sides, find the scale factor. So we're going to match image length over pre-image length. So it doesn't matter where you start. Let's say we start with these two corresponding sides, 5 and 10. It will be 10 over 5, which gives you 2. Let's say I go clockwise and we pick 9 and 18. So we'll do 18 over 9. Again, that gives us 2. So far, so good. And then last but not least, we'll pick our 10 and 20, but we'll put 20 as the numerator. You divide, you also get 2. So, scale factor. That means our sides are proportional. So if I do flip back to the SSS similarity, it says if the length of the corresponding sides are proportional, then the triangles are similar. So we are going to, they are similar using SSS similarity criterion. And again, let's actually practice writing that similarity statement. So if I were to call the first triangle ARC, it will be similar to the second triangle. Take a second. Think about how you would have to name that second triangle. Let's see if you got it. It would be ELD. Okay, So now that we've gone over the 3 criterion, we're just going to do some more examples about similar figures. So let's take a look at example 4. Example 4 says, is triangle ABC similar to triangle DEC? If so, explain which criterion would be used to support your answer. So if you take a look at what's going on here, there's actually 2 triangles combined into one. So the first thing I would do is let's separate these triangles. I actually want to focus just on ABC and DEC without one inside of the other. So let's actually draw triangle ABC without anything else around it. But we have been given side lengths, so let's actually ABC. So from A to C, you're given 2 and 4. So just add them up. The total here is 6. Same thing, from B to C, you're given 3 and 6. So let's just add those up. The length of BC is 9. Now, we don't know the length of AB. There's actually no way we can figure it out as of right now, so we're just going to leave it blank. So now let's look at triangle DEC. So this one's a little bit easier to label. DC is just 4, EC is just 6, and again, we don't know anything about DE. So you'll notice that you're given 2 pairs of sides for these 2 triangles. So if we want to pick one of the criterion, let me write these off to the side here. You have your AA similarity, you have your SAS similarity, and you have your SSS similarity. We definitely want to pick something with 2 pairs of sides, so I'm not going to pick AA. It's either going to be SAS or SSS. Now, we can't pick SSS because we don't know anything about these third sides. So we got to think of a way to use SAS. So think to yourself, do these 2 triangles have any angles, or maybe just one angle, in common? They do. They have angle C. And I know it might have been kind of hard to see at first when you're looking at the picture with both of them together, but when I separated the triangles, they share that corner angle C. So we can attempt the SAS similarity criterion. We just need to make sure our sides are proportional. So let's go ahead and call the big image the pre-image, because we're just going to go from left to right. Let's call DEC the image. And let's just make our scale factors. So 6 goes with 4, but we'll put 4 over 6. This can be reduced. You can actually take out a 2. So this is 2 over 3. If you're a fan of decimals, you can just divide those. That is 0.6 repeating. So that's your scale factor for the bottom sides. And then if you take a look at the sides on the right, 9 and 6, we'll stack 6 over 9. Again, you can reduce this. You can take out a 3, which is still going to give you 2/3, but if you want to change that to a decimal, it's still just 0.6 repeating. So since we are getting the same scale factor for both pairs of sides, and there's an included angle, there's a middle angle between those sides, these triangles are similar using the SAS similarity. So I'm just going to write this down. Yes, because of the SAS similarity criterion. Okay, so anytime you guys see triangles put together in one picture, just separate them. I know you love separating those triangles. All right, let's take a look at example 5 now. So it says, use the figure below to answer the following questions. So part A, is triangle PHO similar to triangle YUM? Fo and Yum. Okay, so if so, we just need to explain which criterion would support our answer. So again, when you look at these 2 triangles, what's given to us? Well, we're given 2 pairs of angles. Now, even though they don't give us any numbers, there's no angle measurements, when you look at the angles, these have a double arc, so that means those are congruent to each other. These have a single arc, those are congruent to each other. So that is the the AA similarity. So we can say, yes, they're similar because of the AA similarity criterion. Now, part B is something we've practiced not super recently, but it wasn't that long ago either. Okay, so now I'm gonna give you some side lengths. If OP measures 2, and if the length of MY is 7, and MU is 9, you want to find the length of OH. So I'm actually going to call that X. That's missing. So you'll notice these are all sides. So what's the one thing we should probably do? Find the scale factor. Anytime you guys are given sides, find scale factor. So let's do scale factor. Remember, image over pre-image. Now I'm going to call the triangle on the left pre-image, triangle on the right image. And when you look at your sides, there's only one option, only one pair of sides that you can pick. It has to be 2 and 7. I can't pick X and 9 because I don't even know what this length is. So I'm going to ignore that for right now. 2 and 7. So this is going to be 7 over 2. 7 divided by 2. That's just 3.5 if you change it to a decimal. Now we have to think about what's the easiest way I can use this 3.5 to find X. So if you remember dilations, anytime you go from a pre-image to an image, you multiply your sides to get the new length. But here, since we're doing image to pre-image, we're actually going to divide by the scale factor to find this length. So X matches with 9. So to get X, I am going to divide by my scale factor. So 9 divided